Hello, geometry students. Today what we're going to take a look at are sections 6.3 and 6.4, which is how we're going to prove triangles are similar. Today what I'm going to do for you is just go over the three postulates and theorems that we need from this section to give you an idea of what they are and how they're used with a few simple examples. From there, we'll go into what more we need to know and be able to do with those. So big idea is to show that two triangles are similar using AA similarity, SSS similarity, or SAS similarity. You should recognize those from before because they have similar names to what we used when we were proving triangles were congruent. Okay, so our first one, AA similarity, stands for angle-angle similarity. Feel free to pause the video to copy this down. But what it's telling us is that if you have two triangles that have two pairs of congruent angles, then we know that the triangles will have to be similar to each other. The reason we don't need the third pair of angles is, if you remember our third angles theorem, that becomes automatic with two pairs of congruent angles. So just two is enough to show that those triangles have to be similar. All right, so we're going to take a look at one quick example here. How can we show that these two triangles are similar to each other? So we really only have one thing marked on this diagram. We have the parallel mark there for EG and HJ. So that's all I really have to go on, is that those are parallel sides. But what's nice about that is I get some alternate interior angles that are congruent. Okay, if you look at EJ as a transversal, I have angle E and angle J that form a pair of alternate interior angles, so those would have to be congruent. I also have a pair of vertical angles that I can use at F. So EFG is going to be congruent to HFJ because they're vertical angles. Now, as soon as you have enough, as soon as you have two pairs of angles, you have enough to prove that these are similar triangles. So since EG is parallel to HJ, then we get angle E is congruent to angle J by the alternate interior angles theorem. Okay, we have angle EFG is congruent to angle JFH by the vertical angles theorem. And then as soon as we get those two pairs of angles, now we can say triangle EFG is similar to triangle JFH. Make sure you write them in the correct order by angle-angle similarity. So if we're writing a proof, it's going to look very close to what we did for congruent triangles. We just have some different theorems to use to actually prove when they're similar. So let's take a look at our second theorem. We have SSS similarity, or side-side-side similarity theorem. So again, pause the video if you want to take a second to copy this down. This theorem is telling us that if we can prove all three pairs of sides are proportional, then the triangles will be similar. So if you look at the example that they have here with triangle ABC and RST, we have our proportionality statement here on the left side. As long as those three ratios are identical, then those triangles have to be similar. So we don't actually need to know anything about the angles as long as we know about all three pairs of corresponding sides. So let's look at an example that's going to use that. Find the value of x that makes these two triangles similar. Okay, well, I need to show that the two sides that contain x are going to be in the same ratio as all the other pairs of sides. So a pair of sides that I can already see both for are xy and pq. xy is 20, pq is 30. So if I set up a ratio xy to pq, 20 to 30, I can reduce that to 2/3. Okay, now if you remember from earlier, 2/3 is actually our scale factor if we want these two triangles to be similar. So I'm going to use that ratio now, and I'm going to set that ratio equal to another ratio of sides that contains x. So I'm just going to erase what I have here. So again, feel free to pause and copy any of this or go back. but just so I have the space to work with. So I have my 2/3 ratio, and I'm going to set that equal to the ratio of side ZY to QR. Okay, now I actually know what ZY and QR equal in this, so I'm going to go back here and erase. And ZY is actually x plus 6. And then QR, I know, is the length of 21. Okay, now remember I said before, there's a lot of different ways you can solve a proportion, so feel free to use a different way than what I'm going to show you. But I tend to use cross multiplication. So 2 times 21 is 42, and 3 times x plus 6 is what I have on the other side. So now what I'm going to do is solve for x. I'm going to distribute the 3. So I get 3x plus 18. Subtract 18 from both sides. So on the left side, I end up with 32, 14, and 3x. Okay, oh, sorry, 42 minus 18 is not 14. That's 32, so it would be 24. Hopefully you caught that. And then divide by 3. So I have 8 equals x for my value, okay, which gives me a length. If I take a look back up, this would be 8 plus 6, or 14. And 14 to 21 is definitely in the ratio 2 to 3, 2/3. So that works. Okay, so now that I've figured out what x is, what I'm going to do is check the last ratio to see if it works. So I know that 2/3, I'll use a different color here, 2/3 has to be equal to the ratio of xz to PR. Okay, well, xz is 12, so let me erase that and put 12. PR is 3 times x minus 2. Okay, I already know what x is, so now I'm going to plug that in below and see if I get a 2/3 ratio. So I have 12 over 3 times 8 minus 2. Let me get a little bit more space here. 8 minus 2 is 6. So I have 3 times 6. And 3 times 6 is 18. So 2/3 equals 12 over 18. And that is definitely true, because if I divide 12 by 6, I get 2. If I divide 18 by 6, I get 3. So I'm in the correct ratio, which confirms that x has to equal 8. Okay, so I figured out for this side as well, if I plug in that 8, I get 3 times 6, which is a side length of 18. Okay, so last theorem that we have to know for this section is this SAS Similarity Theorem, or side angle side. Again, pause if you want to copy this down. In side angle side, it's very similar to the congruence theorem. You need to know one pair of angles are congruent. We call that the included angle. And then the sides around it are proportional. Okay, so not congruent like before, but in that proportion or proportionality statement that we have right here. So as long as we have 2 pairs of sides and we can get that included angle, then we can prove the triangles are similar. All right, so we're going to take a look at one example. Oh, sorry, before we hit, we're going to take a look at a summary here. I'm going to save that last example for class. So we have 3 methods for proving triangles are similar. We have the AA postulate, the SSS theorem, and the SAS theorem. Now, one thing I am going to make you do is write that word similarity in there. Okay, so if you're ever identifying the SSS Similarity Theorem, make sure you include the word similarity, because we don't want to get that one confused with our congruence theorem that we had from before, proving triangles congruent. Okay, same thing, all 3. Even though AA, the only one we have is for similarity, still write AA Similarity Theorem and SAS Similarity Theorem. Okay, so get this copied so that you have a nice summary. Again, what we're going to do is go back to class, take a look at some more examples, try them out, and what I'm going to leave you with right now is I'm going to show you the first example that we're going to talk about tomorrow. Okay, so see if you can read through this example, figure it out, and how did similarity help you figure this one out? Okay, if you're not sure, you can give it a try, but this will be the first example that we do in class. So good luck, and I will see you next time we have class.